Hi and welcome to Vulkan from Zero to Hero.
In this section, we are going to draw our first triangle.
In this video, we are going to create RenderPass and FrameBuffer. Welcome back. In the previous video, we successfully created semaphores for our project. In this video, we need to create RenderPass for our project. A RenderPass represents a collection of attachments, subpasses, and dependencies between subpasses, and describes how the attachments are used over the course of the subpasses. We need to create a header and CPP files for RenderPass. In Vulkan, RenderPasses are represented by VK RenderPass handle. Now let's define our RenderPass class in our header file. First, include device manager header. The class should inherit from WObject class. Add constructor and destructor of this class. We need a load function with the following parameters. Also, we need two functions, namely begin and end for RenderPass. Between these two functions, we can record our command buffers. Begin needs the index of FrameBuffer, command buffer, a color for clearing, and initial values for depth buffer and depth stencil buffer. Notice that depth buffer contains float values, however, the stencil buffer contains an unsigned integer values. The final parameter of begin function is a type of VK subpass contents. The end function just needs a command buffer as an inputted parameter. Like other classes, the class should have release function. For private members of this class, just define a shared pointer for GDevice along with a type def. Now go to the RenderPass C++ file and implement constructor, destructor, and load functions. In load function, first we are going to check the number of attachments for this RenderPass. If we don't have any attachments for RenderPass, then function would return an error. It's really efficient to check the shared pointer of GDevice before continuing. Also, we need to store offsets and size along X and Y axes into local parameters of this class. As I've mentioned before, each RenderPass can contain attachments, subpasses, and dependencies between the subpasses, so we need to define 3 vectors here. We are going to initialize these vectors via inputted parameters. First, store all attachments, then make sure to check subpass description. If it is not available, then create a default attachment references for color and depth. This time check subpass dependency. If it is not available, make sure to create default one. We need two subpasses. Define them like here. It's time to create our RenderPass. So first create RenderPass create info. This structure needs attachments, subpass descriptions, and subpass dependencies. After we've created RenderPass create info, we can call vk create RenderPass function in order to create our RenderPass object. The RenderPass is a type of vk RenderPass. So we need to store its handle in our class into a local member. So far we've created our RenderPass. Now it's time to create frame buffers. We need to create frame buffer for each attachment. First, create an object from FrameBuffer create info and initialize it like this. create FrameBuffer via vk create FrameBuffer function. We should store FrameBuffer object same as RenderPass object in this class. So make sure to define a vector of vk FrameBuffer in RenderPass class. I decided to store both FrameBuffer and RenderPass in one class. You can separate these classes in order to have a better control over the process. After we've implemented load function, let's get back to constructor of this class and initialize the default members with default values. Time to implement begin function. First, make sure we have a correct index for FrameBuffer. Then prepare the clear color, initialize value for clearing depth buffer and a stencil buffer. Okay, create RenderPass begin info. This structure contains the following members. Let's initialize it. First, set type of a structure. I mean S type. Set null pointer for pnext, handle of RenderPass, current FrameBuffer, render area which contains offset and extent. Because offset contains two members, which both of them are type of 32 bits integer, so it's better to change the type of our offsets in our class. I'm going to change it from float to integer. Okay, pass the rest of parameters and call vk command begin RenderPass function in order to start RenderPass. For end function, we just need to call vk command end RenderPass function. In release function, destroy all frame buffers and RenderPass. Now we need a public function in order to get handle of RenderPass from outside of this class. In the next video, we are going to create command buffer.